This example comes out of 8.2, Transformations of Log Functions. We're looking at graphs in this section, and to start this off, I'll take a graph that we looked at in the last chapter, which is just an exponential growth curve, y equals 10 to the x. So this graph passes through a couple of points that I've labeled here, 0, 1, and 110. The asymptote is labeled at y equals 0. The domain is all real numbers, but the range is y has to be greater than 0. Now, the reason why I've drawn that is because what I want to draw is actually the inverse of that. Y equals log base 10 of x. If you draw that, basically everything x becomes y, everything y becomes x. What do I mean by that? It means this is the same as saying x equals 10 to the y. It's the inverse function. So the asymptote is now x equals 0. The curve looks something roughly like this. It goes through the point, for example, 10, 1 instead of 1, 10. It goes through the point 1, 0 instead of 0, 1. The domain and range essentially switch here. X is now greater than 0, and the range is y is an element of all real numbers. So we should be able to draw any log function, just basically thinking of it as in terms of its inverse function, the exponential. Now, we will be asked to do transformations on these. So for example, y equals negative log base 10 of x. Well, hopefully you see right away that that should be a reflection in the x-axis. And so if I reflect something in the x-axis, I essentially turn it upside down. The asymptote hasn't changed here. X equals 0 is my asymptote. The x-intercept hasn't changed because 1, 0 stays at 1, 0, but the point, for example, that we had labeled is now 10, negative 1 instead of 10, positive 1. And you have a curve that looks like this. The domain and range haven't changed from the log function we just drew. X is greater than 0, y is an element of all real numbers. Now, they could ask us to do any number of transformations. It doesn't just have to be one at a time. So you'll get questions like you got in earlier chapters that were to draw something as a progression of graph, to reflect it, then stretch it, then translate it. As a little example here, if we take the one we just did, y equals negative log base 10 of x, and we do a couple more things to it, put a 2 bracket x minus 3 in there. Hopefully everybody agrees that not only do we have that reflection, but now we have to horizontally stretch by a factor of a half, and we're going to have to horizontally translate this thing, to the right 3 units. So this graph is going to look a little bit different than the one we just drew. Importantly, the asymptote is no longer at 0, it's at 1, 2, 3 units to the right. I have an asymptote at x equals 3. The curve still has the same general shape as the last one, but doesn't pass through the same points. So, for example, its x-intercept is now 3.5, 0. It got horizontally stretched by a factor of half, which made it 0.5, and then we had to move it 3 units over. If I take the other coordinate that we had there, 10, negative 1, if I horizontally stretch that by a factor of a half, it'll be 5, negative 1, and then if I move it right 3 units, it becomes 8, negative 1, so a point somewhere over here, 8, negative 1. And so if you're labeling one of these on a test or a quiz, please do label at least a couple of points so that you can show that you've got the shape right. The domain of this graph has changed now. X has to be greater than 3. The range is still y is an element of all real numbers, but by moving one of these log graphs right and left, you do actually change its domain.